So how is this going to work? Electric vehicles are being touted as a replacement for gasoline vehicles across the country. Some states are even outlawing gasoline vehicles in the coming years. Obviously, electric vehicles, by definition, need electricity. They need to plug in to charge up. The question is, where is that electricity going to come from? According to the Wall Street Journal, article came out today, there's already an electricity shortage in the United States. It's not that there's going to be an electricity shortage. There already is one. Power grid operators caution that electricity supplies aren't keeping up with demand and that many states are already struggling to keep up with demand, saying that there will be rolling blackouts this year. Rolling blackouts this year. This electricity shortage is when there are less than 1% of vehicles in operation that are electric vehicles. 1% electric vehicles, and there's already rolling blackouts being predicted. Well, the question is, how much more electricity will be needed for electric vehicles? Maybe electric vehicles don't need that much electricity compared to the existing use. So let's do some math and see how much electricity an electric vehicle does use compared to the normal domestic use. According to the U.S. government, the Energy Division, how much electricity does an American home use? The average is 893 kilowatt hours per month. 893 kilowatt hours per month. Now remember that number, 893 kilowatt hours per month. We'll also do some math on charging station, how many amps, how many watts. Here's your kilowatts down here. And on average, the typical electric vehicle driver, if you drive your car 1,000 miles per month, according to Investopedia, you'll need 250 kilowatt hours to charge your property properly. So 1,000 miles a month, that's 12,000 miles a year. Most people drive more than 12,000 miles per year. Think of the car you have, how many miles are on it, divide by how many years you've had it. More than likely, you probably average more like 18 to 20,000 miles per year. But for the sake of argument, let's just use 12,000 miles a year, 1,000 miles per month. So 250 kilowatt hours over 893, that's almost a 30% increase in the amount of electricity residential power consumption will increase. If you take 250 kilowatt hours, add it on to 893, that's about a 30% increase. Well, before that even happening, we have electricity shortages. It doesn't take a rocket science to figure out that this is going to be a problem. If the Wall Street Journal is already saying there's going to be rolling blackouts during heat waves or other peak periods, then the risk of electricity shortages rising because traditional power plants are being retired. What does that mean? What that means is if electric vehicles are supposed to be more than 1% of the current use, the power supply doesn't exist. There may be more factors to this than meet the eye. There may be more absorption of this demand than is obvious just from this. I'm a simple guy. I just go by what the math says. Maybe domestic power use is a small percentage compared to commercial power use. Maybe there is flexibility in the charging if it happens at night. All I'm saying is electric vehicles are 1% of the market. The intention is to have them be 70 or 80% of the market within a decade. The state of Washington has passed a law that does not allow for gasoline or diesel vehicles to be sold or even registered in the state of Washington after 2030. 7 years away, roughly. If that's going to be the case, where's the electricity going to come from? Again, this isn't about whether or not electric vehicles should or shouldn't happen. That's not the opinion. Well, we're just doing a rational, logical observation of, if electric vehicles are going to happen, where does the power come from? Where does the electricity come from? Put your comments below. Let us know what you think about this potential conflict between demand and availability. Look, we already see what happens when supply and demand doesn't match. In the last 18 to 24 months, there's been supply and demand problems with real estate, gasoline, motor vehicles, appliances. And what happened to the price? Went up, or you couldn't get it. If the same supply and demand pressure hits the energy market, most suitably electricity, what that's going to do? Is that going to raise the price of your electric bill? If your electric bill normally was $200 or $300 a month, is it going to be $400 or $500 a month? Or is it going to make rolling blackouts? Is it going to make restrictions on usage of electricity? How would an electric company limit your use? Well, here's an article that claims that this person found a remote switch installed on his air conditioner by the power company without their permission to shut off their air conditioner. Rocky Mountain Power has installed switches on AC units that allow it to remotely toggle off the air conditioning to save energy during heat waves. So, will this be the wave of the future? If there are hundreds of thousands or millions of new electric vehicles in the marketplace, sapping electric capacity from the grid, how will the power companies deal with it? They're not building any new power plants. And if there are already energy shortages in many parts of the country, as electric vehicles come online and are need to be charged from a home charging system, the power company that provides electricity to the residents is going to find itself with a severe shortage. So maybe they'll use these air conditioner kill switches to shut off your AC. AC is one of the biggest draws of a system. It's also the biggest spike energy usage, because when it gets hot, everybody turns on the air conditioner all at once. Where other things like stoves, hot water heaters, they cycle on at different times. Stove is an intermittent use. Hot water heater, intermittent use. A dryer, intermittent use. Those are the highest amperage draws from an electrical grid. And because they're intermittent, you run your dryer for a half an hour. Your stove might be on for 20 minutes. Bake some cookies. Your hot water heater kicks on and off to keep the water warm. Air conditioner, once it gets hot, it kicks on and it stays on for hours. So it's going to draw a lot from that electrical grid. The power companies might have an incentive to shut that off, to keep their grid supply evenly distributed. Is that what you want? Again, we're not drawing a conclusion whether or not electric vehicles should or should not happen. We're just pointing out the future, thinking ahead of what might be some of the problems and how to prevent them. Whether you're a homeowner, you are an electrical company, government agency, these are all factors that have to be taken into account, because many times this planning doesn't happen into account in advance, and it only is realized once the problem happens. Could be 2028. Oh, we have all these electric vehicles. They're all plugging in, and it's using up all the power. People can't run their AC. There's not enough power to go around. There's blackouts. There's brownouts. So being aware of this need, again, maybe there's, smarter people than me that are figuring this out at the government level. What do you think? Do you think there are strategies for this happening at the electric company, at the government level? Are people thinking of this? Put your comments down below. Let us know what you think about electric vehicles in general, and also about the power grid being able to support these high drain battery recharge, 250 kilowatt hours. It's like a third, 20, 30% of what your house normally uses, a typical U.S. house.